you see that this is household size 2, right?
Yeah.
For household size, we don't have household size new household size m as just independent variable, but we use this instead. And last time we discussed that because the minimum number for the household size is 1. So this is the first independent variable for household size. It must be the increment number from the minimum value 1. And next is the 2 minus 3 and so on. For the number of cars, the minimum number for the number of cars for a household is 0. So incarnate is just the value of the number of cars minus 0. And to be clear that we can draw the graph. It's the number of cars. We are allowed to have 0 or 1 to up to 3, right? Up to 3. And this number of trips. For the supply relation, when incur equal to 0, then it's somewhere here. When it's equal to 1, for the supply, keep slope, and then the increment on slope. So if we don't have this, then what happens? If we don't have this, if we don't have this, then when incarnate equal to 0, this becomes 0. Okay. Sorry, when it's equal to intersect, right? But then incarnate equal to 1, then it's also intersect. So that means the graph will be something like this. And that is not correct. If you don't have this, in other words, when incarnate equal to 0, then we get some constant term. For this, for the household size. When this incarnate trips intersect plus 1 beta plus 0 plus size. So this is correct because it has some change because we have this term. Incarnate equal to 1, then this equal to 1 times 1. But when incarnate equal to 2, then number of trips become plus 2 beta incarnate. Right. Plus 1 times beta incarnate. So it's allowed to have this shift in slope. So my point is that 0 here is the minimum value. Okay. But for the household size, the minimum value is 1. It's not 0. Okay, it's 1. So that's why we don't have household size in as the independent variable, but we have to use the household size 2, which is have to minus the minimum. That's 1. So this is the mean value for the household size. So how I draw this, I just draw it by hand. You can see this. I think I draw it by hand. Or not. All this has no problem, right? But you asked me about spline. You know spline? Yeah, I think I draw it by hand for the spline. Let me check the correctness. So all the F statistics, the same, 2.29 for the three equations, 1.2 to 1.5, because they say the same thing, but just different ways, using spline, using the variable increment, and the variable model. Okay. So this part is straightforward. Okay. So now we move on to homework 5. Homework 5. So the homework for solution is here on the desktop. You can download it after class. So let's see homework 5. There are 7 pages. So last time I've gone through this quickly. Now I will repeat this again. But we repeat based on the assignment. So for the growth factor method is simple, so we don't have assignment for the growth factor. We already have assignment for gravity model. And I will also give you this. Should I? No, I will not give you this. So you should develop this yourself. Because it involves the iterations. I have to perform iterations. It's for homework 5.1. So this file is the solution file. Oh, you cannot see it. So this is the solution in Excel, where each cell contains equations. Here, equations, if statement, and all of these match the assignment. Because the assignments show you the iterations for the gravity model. So they just ask you on particular step that how can you validate this calculation? So to repeat the calculation step. So let's say here's our gravity model calibration. So the calibration here means we want to develop non-parametric friction factor function, the F function, which is this one, F. So F here is a friction factor in between zone I and zone J. Okay. When the friction factor is high, then the temperature change between I and J also high, because trip interchange between I and J is directly proportional to the friction factor. And in this assignment, we will look at non-parametric friction factor function. So that means this friction factor cannot be expressed in a closed form formula. We don't have an equation for this. What we have is just we have to develop a step function. So basically in the lecture note I have 30 slides, but the one that related to the gravity model beginning here, start at slide 13. So basically friction factor is the thing that we're going to determine, so we call calibrate. Calibration step is using the collected data, the data of the production, the data of extraction, and the data for the temperature change. If we know this, then we can develop the friction factor for the non-parametric. Okay, so this is the calibration problem. So we don't do this. Okay. This is the parametric function because we have parameters b. Okay. This friction factor is the inverse of this CAJ. What we're going to do is this non-parametric. So we're going to develop this. That the friction factor is the function of the impedance or travel cost between two zones. And the friction factor is constant for the interval of 5 minutes or 5 for the impedance value. Between 0 to 5 for the impedance or for the travel cost, friction factor is the same as this value. When cost is higher, then the friction jump up and then down. So we're going to develop this. And the process is explained as given in detail in the PowerPoint. So the input is the today data. The base year travel time metrics is what we must have. Okay. And the observed year temperature change is the matrix between any two zones. And we also get the productions and attractions for the base year. Then this is the first step. First, create time interval. We say 5-minute increments. Okay. So beginning at 0 to 5, 5 to 1 to 10, and so on. Okay. And then determine the zone pair from the base year data. That which zone pair in the cell that belong to this category. And then also note down the observed strip from the temperature change from the base year. So this first step for the assignment, let's say this assignment is given the base year trip time matrix. So this is minutes, travel time between any two zones. And this is temperature change